Now let us discuss about the concept of sensible heat factor. Sensible heat factor is given by the ratio of sensible heat to the sensible heat plus latent heat, and this sensible heat plus latent heat is the total heat Q. So sensible heat factor is Qs divided by Q, and its value will always be less than or equal to 1. 1 will be possible only when the value of the latent heat is 0. You can see this expression. If the value of QL goes to be 0, then the expression of the sensible heat factor becomes QS divided by QS. So it becomes 1. So when the latent heat value is 0, the sensible heat factor is equal to 1. Otherwise, the value of sensible heat factor varies between 0 to 1. It depends upon the value of the sensible heat as well as the latent heat. Now you can see the psychrometric chart where the process of cooling and humidification is shown, followed by the line 1 to 2, and 1 to A is the latent heat part. This shows the latent heat removal and this shows the sensible heat removal. And if we see on the uh, enthalpy scale, you can see it here that this is the value of H1, this is the value of HA, and this is the value of H2. So latent heat part is given by, this is the latent heat part, it is equal to H1 minus HA, and the sensible heat part is given by HA minus H2. So we can write that the value of Qs is equal to H2 minus HA minus H2, HA minus H2, and the latent heat part is H1 minus HA. So delta H A to 2 for the process of sensible heat removal, and delta H 1 to 2 for the total heat removal. And we know that the sensible heat removal is given by Q given by 0.0204 cmm delta T divided by the total heat is given by sensible heat part, and this is the value of the latent heat part given by 50 cmm delta W. So we can say that it is equal to 0.0204 cmm delta T divided by 0.02 cmm delta H. This is the value of the total heat removed, and it can be written as MA into uh, delta H. And when we will put the value of MA, it comes out to be 0.02 into cmm. Once again, this value is written here. This is the value of the sensible heat factor. And here on the psychrometric chart, you can see we have shown the contribution of the total heat. This is the contribution of the latent heat, and this is the contribution of the sensible heat. So sensible heat factor is given by delta H A to 2 divided by total heat, which is equal to delta H 1 to 2. If we subtract 1 from both the sides, we subtract both the sides from 1, then we will get delta H 1 to A and delta H 1 to 2, V is equal to 1 minus sensible heat factor. Now once again, sensible heat factor is given by delta H A to 2 divided by delta H A to 2 and delta H 1 to A. And then what we have done, we have divided the numerator and denominator by this particular value. So in the numerator we get 1, in the denominator here we get 1, and here we get delta H1A divided by delta HA2. And if you will see this particular value, you see it from here, it is equal to delta H1A, which is in the numerator of this equation, and divided by delta HA to 2, and this is in the denominator of this particular equation. So this particular value is tangent theta. So here it is written as tangent theta because this is the perpendicular and this is the base. So perpendicular by base is tangent theta. So sensible heat factor is equal to, once again written as 1 over 1 plus delta H1A delta HA to 2, and delta H1A is latent heat, and delta HA to 2 is sensible heat. And now we can put their values, which is equal to 50 cmm delta W, and sensible heat is 0.0204 cmm delta T. And when we will divide these two values, we will get 2451, and cmm and cmm cancels out, and we are left with delta W by delta T, and this total value is once again tangent theta. But we need not to worry. We should remember the equation that sensible heat factor is equal to Qs divided by Qs plus Ql. That is the most important equation that we need to remember. You can forget this equation, no need to remember it. So once again, if you will see here, You can see the previous chart. This is the angle theta here. This theta is the tangent theta, and theta is given by uh, theta is the slope of the sensible heat factor line 1 to 2 on the psychrometric chart. So theta is a function of the sensible heat factor. Now how to plot or draw this sensible heat factor line? So there are three methods to plot this sensible heat factor line. SHFL. SHFL stands for sensible heat factor line. So the method one is, what we can do is we can, if we know the values of QS and QL, then we can take their values on a particular scale and draw the sensible heat factor. Let us see how. Let us say that QS value is 80 kilowatt and QL is 20 kilowatts. So total load is 100 kilowatts. So what we can consider is 1 centimeter is equal to 20 kilowatt, and this is the value of, let us say, QL. Then 4 centimeter will be equal to 80 kilowatt, and this value is equal to QS, and the total of these will be 5 centimeter, which is equal to 100 kilowatts. So this is the total load Q. So now what we can do is we can plot 4 centimeter length, which represents the sensible heat, and 1 centimeter length as the latent heat. And first of all, we can draw this line, and at the end of this line we can draw the perpendicular line, and we can join this point to this point, and this is the sensible heat factor line. And this is how it is drawn, by knowing the sensible heat as well as the latent heat. Second method is, we can calculate the value of the tangent theta if we know the value of QL and QS. Once the value of theta is known to us, we can draw QS, which is equal to 4 centimeter, then plot this particular line, and then plot this QL. So wherever it intersects, this, you get this line as the sensible heat factor line. That is the another way of drawing it. Third method is, in a psychrometric chart, a scale is given on the for sensible heat factor on the right hand side. As you can see here on the right hand side of the psychrometric chart, this scale is given, and here the value of the sensible heat factor is 1. This corresponds to a particular value on the psychrometric chart. If you will see the psychrometric chart, there is a circle, and this circle is known as the alignment circle. This is the alignment circle. It is a sort of a reference circle for drawing the sensible heat factor. So it is a reference circle for drawing the sensible heat factor, and it is usually made at a temperature of 25 degrees Celsius dry bulb temperature and 50% relative humidity in most of the psychrometric charts. In some of the psychrometric charts, the dry bulb temperature could be 26 degrees Celsius, but the value of the relative humidity is 50% only. And it can be located at any particular point, because corresponding to this particular point, if you will draw the horizontal line, you will get a value of the sensible heat factor which is equal to 1. So this is a reference point, so need not to worry wherever it can be drawn on the psychrometric chart. So what we have to do, suppose now we have calculated the value of sensible heat factor, which is equal to 80 divided by 100, which is equal to 0.8. So what I can do is I can join this line with the 0.8. So this is the sensible heat factor line. Had the value of sensible heat factor been 0.7, let us say, then this could have been the sensible heat factor. Okay, then this would have been the sensible heat factor line. So we have to join the alignment circle with the calculated value of the sensible heat factor, and it gives us the sensible heat factor line. So basically there are three methods. Once again, the first method is, we know the values of QS and QL. We can draw a horizontal line which is representing QS, then the latent heat line, and then we can join this line and we will get the sensible heat factor line. Once we get the sensible heat factor line, we can, if we know the initial state of the air, suppose the initial state of the air is at point I, so we can draw a line which is parallel to this sensible heat factor line. So this line now becomes the sensible heat factor line. Okay, and this is the second method where we have drawn the tangent theta, and from the value of the tangent theta we can calculate the sensible heat factor. If we have the psychrometric chart, and on the psychrometric chart there is a sensible heat factor scale, we can use it also by joining the alignment circle with the sensible heat factor value, which has been calculated based on the values of sensible heat and the latent heat. This was about the sensible heat factor, which you have now, I hope, understood. So I will end it here.